acid bases. At its basic, an acid is anything that can release a hydrogen. So like bicarbonate is H2CO3, right? Well, that has two hydrogen groups. One of them, it can deprotonate and it can release it. So when we take a look at an acid, right? And here's an acid, hydrochloric acid. Hydrochloric acid is considered a strong acid because if you put hydrochloric acid in pure water, right, pH of 7, what happens is it will remove its hydrogen and deprotonate. If you put hydrochloric acid with other hydrochloric acid, all right, so you're mixing two strong acids. Because they're both strong acids, they will also deprotonate and remove a hydrogen. So an acid, a strong acid, is any kind of a compound that can release their hydrogen. A weak acid, like carbonic acid, got a pH about 4 to 5, right? What happens with carbonic acid here is it will deprotonate and act like an acid in certain circumstances. Let's say that your blood pH is 7 or maybe 6.9, right? At that point, carbonic acid will work like an acid. It will deprotonate, remove the hydrogen. So, but if we put carbonic acid into your stomach, stomach has a pH of the solution in your stomach, that gastric juice has a pH of 1. So what happens with carbonic acid then? Well, with a pH of 1, the gastric juices already has huge amount of hydrogens in it. So what happens is this carbonic acid being weak is less likely to release its hydrogen, right? If anything, the bicarbonate that we see will actually pick up hydrogen. So when we look at an acid is anything that can give its hydrogen away. A strong acid always gives its hydrogen away, no matter what type of solution I'm putting that acid into. A weak acid only removes its hydrogen, puts it into solution when you put it in a certain pH, right? Maybe a higher pH solution. So if I put carbonic acid in pure water with a pH of 7, carbonic acid will deprotonate, act like an acid. Now, if I put that carbonic acid, let's say in, right, in urine, and the urine's got a pH of 4, what happens? Well, pH of 4 means that there's already lots of hydrogens in that urine. So if I introduce carbonic acid at that site, at that location, with that lower pH and higher hydrogen, what happens is, since it's a weak acid, it can't deprotonate. And it either stays a carbonic acid, right? Or if you have any bicarbonate ions, it will act like a base, right? Again, weak acids, the only difference between a weak and a strong acid is where it can work and what solution does it deprotonate at. Strong acids always deprotonate, even at a low pH environment. Weak acids only deprotonate when there's a higher pH, right? Now, strong bases like sodium hydroxide lie. Keep in mind, a strong acid will burn you, a strong base will burn you as well. Sodium hydroxide will remove a hydroxide. That hydroxide then will dissociate, and right, by removing the hydroxide, that's what makes it a base. So instead of releasing hydrogen, it's releasing a hydroxide ion. This hydroxide can then, if you put it with hydrochloric acid, right, you have the sodium and the chloride over here working together to form salt. And then the hydrogen and the hydroxide, right, forming water. So if you put these two, really strong acid and real strong base together, by the end of the reaction, you get salt water. Crazy, right? So a strong base will remove hydroxide anions. Once you do remove that hydroxide anion, that hydroxide anion can neutralize any hydrogen that's already in the solution. In the process, that hydrogen that's in that solution, again, right? Let's say we have a container of hydrochloric acid. strong acid, all right? We know that in that solution, there's gonna be like half of it's gonna be hydrogen, half of it's gonna be chloride. If we put a strong base there, the strong base dissociates as well into hydroxide, anion, and sodium ion. The positive and negative charges attract each other. So sodium and the chloride attract and bond, an ionic bond, forming salt. And then the hydrogen and the hydroxide form a bond, forming water, right? So a strong base will neutralize a strong acid by reacting with the hydrogen already found in that acid. So when we take a look at this, bases then, because it removes hydrogen, right? By removing that hydrogen, you neutralize that acid. So bases remove hydrogen from a solution, neutralizing the acid there. Buffers resist changes in pH. So the best example of buffer is this one, carbonic acid. It can work as a weak acid when we drive the reaction to the right over here, or it can act like a weak base. Keep in mind this bicarbonate has a negative charge. Usually bases have a negative charge. Why? It's because then it can attract the positively charged hydrogen, right? So when bicarbonate anion is found and there's an excess amount of hydrogen, meaning what, right? If we have bicarbonate and our blood pH, instead of being 7.4, is at 7. Blood pH of 7 means I have more, it's slightly acidic. Slightly acidic means we have more hydrogen in our plasma than we should. So the bicarbonate then acts like a base. It reacts with hydrogen because now we have a pH of 7, there's a lot more hydrogen in our blood. So the bicarbonate reacts with the hydrogen, forming carbonic acid. By removing the hydrogen now, we decrease the hydrogen concentration. The pH starts to go up towards normal. Perfect. That's how this can act like a base and it can act like an acid. This combination right here, that one, right, carbonic acid bicarbonate pathway is incredibly important in our body. So important, there's no real way to give it its due. So we're gonna see, there are 3 types of buffer systems in our body: carbonic acid, bicarbonate, protein, and we'll talk about in a second what that is, and then phosphate. So, right, again, normal blood pH is 7.4. What happens if blood pH right here increases? As blood pH increases, it gets to 7.8, 7.6, right? That making it more basic than it should be. So if we think about what happens if we're more basic, 7.6, 7.8, well, what we need to do somehow is get more hydrogens, right? Hydrogens will lower the pH from 7.6 closer towards 7.4. So what we need to do somehow is to then, if we have an increased blood pH, we need to lower it towards normal. And that's what the buffers here do, right? There are a couple things that happens to lower our blood pH. One of the things that can happen is this. Normally, our urine is slightly acidic. At that point, if we're already basic in our bloodstream, do we want to urinate out excess hydrogen? No, right? We want to retain the hydrogen so then it can increase our hydrogen concentration in our body. So as the hydrogen concentration increases, I can start decreasing the pH. So one of the first things that happens is I decrease the secretion of hydrogen into the urine. By decreasing the secretion, I decrease the loss of hydrogen. I retain hydrogen. Perfect. Retaining the hydrogen means you are able to increase the hydrogen concentration. Again, the problem is you're alkalotic, you're too basic. We want to become more acidic as a response. So by reabsorbing the hydrogen in our kidneys, we're able to reabsorb and make sure that our blood pH doesn't elevate too much. It can decrease it. The second thing that happens is in the lungs. It's pretty interesting, right? Remember, if you look at this buffer system, in order to make this, and I'm gonna do a new share on the whiteboard, right? Keep in mind, what do we do? Whoops, right? We're gonna take carbon dioxide, add it with water, and we're gonna have, I need a pen, but, right, to make bicarbonate or carbonic acid. So what we notice is this, right? And then that can move to the right or left to make this. So this whole reaction that we see, it's hard to write it like this when we just from the mouse, so yeah, that's bad. All right, so that reaction that we see here is HCO3 minus. That was bad. So what happens is, if we increase carbon dioxide, can you guys see what my whiteboard and my ridiculously bad handwriting?
Yeah.
Okay, so what happens if I increase carbon dioxide right now? If I increase carbon dioxide, I push the reaction to the right. By pushing the reaction to the right, I form from the carbon dioxide and water more carbonic acid, which then deprotonates. Remember, my problem is my pH instead of 7.4 is 7.8. It's too high. So when I want more hydrogens, right? If I have more hydrogens that I can release into the bloodstream, what happens to my pH? It goes from 7.8 down to 7.6. If I even add more hydrogen, it gets more acidic even more, 7.6 to 7.4. So when we are alkalotic, we need more hydrogens. More hydrogens will make us more acidic, which is exactly what we want. We're at 7.8, we're already basic. We need to make it go down to 7.4. How do we make our pH go down to 7.4? Adding more hydrogen. One of the ways we do this, by increasing our carbon dioxide. How do we increase our carbon dioxide? We are going to decrease our respiratory rate. When we decrease our respiratory rate and hypoventilate, we are going to, when we hypoventilate, our R is respiratory rate, right? By hypoventilating, we breathe less. If we breathe less, we exhale less carbon dioxide out, right? So we are then going to retain that carbon dioxide, pushing this reaction to the right, increasing the hydrogen in my plasma, which will then hopefully neutralize what happened with my alkalosis, right? So when we're alkalotic, our pH is too high, right? Instead of 7.4, we're gonna see our pH is at 7.6, right? Or 7.8. So if our pH is 7.8, we need to move it down. So then it can move to 7.4. If we do that, and when we try doing that, we need to increase the hydrogen. Perfect, right? Now, opposite's also true. So we know that if we increase the carbon dioxide, we can increase hydrogen. What happens? Well, the opposite's true. If we decrease the carbon dioxide in our body, well, that was bad, right? If we decrease the carbon dioxide, then we will then decrease the amount of hydrogen we produce, right? It's getting progressively worse, guys. If we decrease the carbon dioxide, we decrease the hydrogen. If we decrease the hydrogen concentration here, right? By decreasing it, the opposite will be true, right? So by decreasing carbon dioxide, the reaction produces less hydrogen. If we produce less hydrogen, we become more alkalotic, right? So respiration rate plays a big role in acid-base balance. which is kind of crazy to think about it, right? But it does, it plays a big role in acid-base balance. So let's take a look at what I mean, all right? So we have, at that point, we'll come back to this, all right, in a second, but keep in mind that respiration right here. If we are alkalotic, our blood pH is increased. We need to decrease it. How do we decrease the pH from here? We need to retain hydrogen. Kidneys start reabsorbing the hydrogen, right? And we release more bicarbonate into urine, making our urine less acidic, more basic. Again, at this point, we're trying to become more acidic because we're so basic, right? The lungs, what do? Right? We increase blood CO2 by hypoventilating. Now, there is a limit, right? If you completely stop breathing, yeah, you retain a lot of carbon dioxide, but you're gonna die. So there's a limit to how low our respiratory rate can become. Instead of 12 to 14 breaths per minute, it might go to 6 breaths per minute. As your respiration rate decreases, you exhale out less carbon dioxide. And by exhaling out less carbon dioxide, you build up carbon dioxide, pushing that reaction to the right to produce more hydrogen here. All right,
Dr.
yes.
I'm frozen again.
Oh, dang it.
Yeah, it's on the,
Yeah.
just the cover, it says chapter 27.
Okay, cover page?
Yeah, you went to the cover page.
I went
I
to
don't know why it keeps doing that.
It happens on Thursdays. I don't know why.
It's a special time.
All right, let's see, is this better?
I still got nothing.
No, it's still there.
Okay, right here. Can you see it now?
Yes, okay. There we go.
Yeah, it's they did this great idea of doing a force update for Zoom. So yeah, I mean, I understand people are worried about getting hacked, you know, but yeah, it's not very good. Right. So what happens is here, right? Carbon dioxide, water, right here. You're able to, again, the more carbon dioxide, the more you push that reaction to form carbonic acid. Let me see if I can make it better, which is going to be better me drawing it before. All right, so more carbon dioxide, the more reactant, the more I push to the right, more hydrogen is produced. And again, if we are alkalotic, high pH, 7.8, in order to get to 7.4, we need to lower the pH, right? How do we lower the pH? The only way to lower the pH of anything at any time is to increase the hydrogen concentration. So when we are basic, we need to increase hydrogen. And that's what all these mechanisms are for, right? In the kidneys, you retain hydrogen instead of releasing it. You get rid of bicarbonate instead of absorbing it, right? So then pH of the urine, normally slightly acidic, now will be basic, like a 7.4. So then you can get rid of excess base and retain more hydrogen. In the lungs, right, we retain more carbon dioxide, which allows us to make more acid, more hydrogen. In the buffer system in our blood vessels, we produce more hydrogen. Also, then we can increase hydrogen concentration. So then if we increase the hydrogen concentration, we add hydrogens to our plasma, making the plasma more acidic than before, lowering the pH from 7.8 closer to 7.4. Opposite's also true, right? Again, with one of these, if you know one instance, you know the other one because it's completely the opposite, right? If my blood pH is low, 7.0 instead of 7.4, that's acidotic. What happens then? Well, we need to get rid of our acids. So, our lungs, right? Marianne? Sorry, guys. Right?
He wants to go outside.
Alley be right there. All right, so if it's at 7.0 instead of 7.4, we're way down here, right? In order to normalize it, right, I love my dog, my guard dog, who just bark when somebody's already in the house.
Oh, I thought he
Right?
wanted.
That didn't help, right? He's already in the house. But so what happens is, he's not a guard dog either. Right? So blood pH instead of 7.4 is at 7.0. Keep in mind, there are things that can cause this, right? Diabetic ketoacidosis. Well, it's got the name acidosis in it, right? So what happens when you have acidosis? Blood pH is low. Now we have to increase it. So if we're alkalotic, we need to increase hydrogen. If we're low, we need to get rid of hydrogen. So one of the things we do is, right, in the respiratory rate, instead of hypoventilating, we hyperventilate, increasing the respiratory rate. When you increase respiratory rate, you're blowing out more carbon dioxide. So what happens? If we're blowing out more carbon dioxide here, we need to make more carbon dioxide by getting rid of hydrogen, by binding it with bicarbonate to form carbonic acid, then producing carbon dioxide. So by blowing out the carbon dioxide, we are getting rid of acid. And then our pH will go up, right? Another thing, the kidneys. Kidneys does a great job with dealing with acid-base imbalances, but it takes a couple days. So it takes time for it to accumulate. In the lungs, it's real quick. If you have a problem with your acid-base balance, your lungs and your respiratory system is able to increase and decrease respiratory rate. But there's a limit, right? To how much you can hold your breath, to how low your respiratory rate is. There's also a limit to how fast you can breathe. So when we have acidosis here, and your blood pH is lower than normal, what we're trying to do then in the lungs is try to increase your respiratory rate so you can blow out more carbon dioxide. If you keep increasing it though, right, you will get tired. So there's a limit at that. Now, usually we have enough buffers and our respiratory and renal compensation is good enough that we are then able to excrete more hydrogen, which is now going to make my urine more acidic. We're also going to reabsorb more bicarbonate. So then again, why would we want to reabsorb bicarbonate in the kidneys now? And I do want you to think this should make sense. We want to reabsorb more bicarbonate in the kidneys because then we can introduce it in the bloodstream, and now I have more bicarbonate with its negative charge in the bloodstream. Any stray hydrogens it can bind to and neutralize, allowing us to get rid of excess hydrogens. And that's what we're going to see here. By getting rid of the excess hydrogen ion, we're able then to increase our pH towards normal, right? So these are the compensations that we see when we come up in just a second, right? Buffers prevent, right? If pH rises, buffers bind hydrogen. If pH falls, buffers release hydrogen, right? Protein buffers. You guys have seen protein buffers before? Probably not. So what I'm going to show you is how a protein can act like a buffer, right? How does a protein act like a buffer? So hopefully it's resuming share. For some reason, once I switch this right now, right, it completely changes it. So let me go back here on a new share and on the whiteboard. You guys don't see that, do you?
I can see some writing.
I can see it. Can you move the cursor at all? Yeah, there you go. Well,
yeah.
Okay.
All right. So what I want you to understand is that in the protein buffer system, right? So we have three buffer systems. We've talked about the bicarbonate one a lot. The protein buffer system only works because on one side of a, right, when you look at an amino acid has an amine, right, nitrogenous end, and an acid end, right? So on one side is an acid. It can release hydrogen. Another side, right here, let me see if I can write, we can see that, right, in an amino acid, it's got the amine group, the nitrogenous group. That nitrogenous group in an amino acid can pick up hydrogen and act like a base. So in terms of protein, a protein has on one side an amine group that can pick up hydrogen and act as a base. Another side, the acid portion, can release hydrogen and act like an acid. That's why we call it a buffer system, right? So the buffer system means that if you have too much hydrogen in your body and your pH is 7.0, how does the protein buffer system work? Well, the protein buffer system will try to pick up any stray hydrogens because there's too much, right? That's why the pH is so low, because there's so much hydrogen going around in your bloodstream. The protein buffer system on the amine end, the NHN of the amino acid, well, it picks up an extra hydrogen. As it does so, you've released and neutralized a hydrogen. On the carboxylic acid end, it picks up a hydrogen as well. In doing that, what happens is you are buffering and removing hydrogen. Now, if there isn't enough acid, what happens? So there's not enough hydrogens, your pH is at 7.8 instead of 7.4. Not enough hydrogens in your cardiovascular system, in your plasma. What happens then? The protein buffer system does this. On the amine end, well, there isn't enough hydrogens anymore. Do you want to pick up even more hydrogens and neutralize it? No. So on the one end with the nitrogens, well, we don't pick up any extra hydrogens there. On the carboxylic acid end, we remove hydrogen and we deprotonate. That way we can increase the hydrogen concentration in our plasma. Again, the problem then when you're basic or alkalotic is you don't have enough hydrogens. A protein buffer system means that on one end, you can release hydrogen, the carboxylic acid part of the protein, and on amino end, it can pick up hydrogens, acting like a base on that end. On the other end with the carboxylic acid, it can act like an acid, right? So that's how it works in a buffer system. So in terms of acid-base balance, achieved through carbonic acid and bicarbonate system, especially the respiratory regulation. As carbon dioxide levels increase, hydrogen and levels will also increase. There is a direct relationship between carbon dioxide and hydrogen. I'm going to write that down right here, right? Direct relationship between CO2 and hydrogen, right? So when we have high levels of CO2, we're gonna have high levels of hydrogen. When both occurs, when we have high levels of hydrogen, our pH decreases. Remember, hydrogen and pH inversely, right? As carbon dioxide levels decrease, pH increases. Because as carbon dioxide decreases, hydrogen concentration decreases as well. Now, how can we adjust the carbon dioxide levels? By hypoventilating or hyperventilating. Hypoventilation increases blood carbon dioxide levels. Why? By hypoventilating, I'm going to increase CO2 in my body because I'm not exhaling it out. If I increase CO2, I'm going to increase the hydrogen, which will then cause a drop in pH, right? Opposite is true with hyperventilation, right? With hyperventilation, and probably easiest to write it this way, hyperventilation here, and hypo on the over here. Right? So when you hyperventilate, you get rid of excess carbon dioxide and the carbon dioxide levels decrease. Since their hydrogen and carbon dioxide are directly related, the decrease in carbon dioxide leads to a drop in hydrogen, which leads to a pH increase. Now we're going to see that there are causes where ventilation's a problem, right? And we'll talk about that in just a second. So let's talk about we kind of mentioned these. Alkalosis and acidosis. Now, for some reason, when I try to go through other type of my other notes, right? I want you to review the notes specifically on the acid-base addendum, and it should be a little bit better than what we see here. But when I try to open it up, it doesn't open and go on this window for some reason. I can't share it, right? So I will just use this for now. There are two primary causes of acidosis and two primary causes of alkalosis, all right? Now, if you know the respiratory and metabolic acidosis, the alkalosis are completely opposite examples. Meaning what? When we have acidosis, pH is below 7.35. Alkalosis, pH is above 7.45. The two causes of acidosis. One, respiratory cause. So in the respiratory cause, the problem is you have respiratory system that's starting to fail, right? That's causing the issue. If the respiratory problem is causing the issue, what are the chances that we will see the respiratory rate actually can cause and help the situation? You're not, right? So when there's a respiratory cause to either acidosis or alkalosis, there will not be a compensatory response, right? Compensation is two types, right? One type of compensation is respiratory, by increasing or decreasing the respiratory rate. The second response is renal, right? And depending on if you have acidosis or alkalosis in the renal system, we can either secrete hydrogen. They just do respiratory. Right, now I know why people don't like this one. See that? I somehow erased it, right? The renal response is either releasing or secreting hydrogen and reabsorbing bicarb right? She is reabsorbing bicarb. I don't need you, Sari. Right. So the renal response, the respiratory response right here is increasing or decreasing respiratory rate. Deceasing. Right. The renal response, either secreting hydrogen and reabsorbing bicarb. When we do that, urine more acidic. But remember, there's a limit to how acidic you can make your urine. The last thing we want to do is urinate out urine that's got a pH of 1. It'll burn everything. Right? So there's a limit to everything here. So in the renal response, we can secrete hydrogen and reabsorb bicarb, or we can reabsorb hydrogens and secrete bicarb. By secreting, I mean getting rid of, excreting it. So let's think about respiratory acidosis first. What happens when we have respiratory acidosis? Respiration is the cause of this. What will cause us to have respiratory acidosis? Well, let's take a look, right? Respiratory response, we know that there's a direct relationship between carbon dioxide and hydrogen concentration. So we have decreased or increased carbon dioxide here. We can have increased hydrogen and increase the acidity, right? And we have respiratory acidosis. Respiratory acidosis is caused by inadequate ventilation, i.e. hypoventilation. So I hate the, inadequate. So hypoventilation can cause respiratory acidosis. You guys know what is the most common cause of respiratory acidosis and hypoventilation in America? Narcotics. Narcotics and narcotic drugs, right, is the most common cause of respiratory acidosis. What happens when you take narcotics, and it doesn't have to be heroin, but if you're taking some opiates, what happens is it decreases your respiratory rate. As it decreases your respiratory rate, it's going to lead to, right, it's going to lead, right, in terms of this, right, to the buildup of carbon dioxide. And buildup of carbon dioxide means a buildup of hydrogens. They're directly connected. With the increase in hydrogen, we're going to have acidosis. So respiratory cause, the most common one in America, is narcotics. Right? Now, what kind of response should we see? There's two responses, respiratory and renal. Well, we know when it's a respiratory cause, we shouldn't have a respiratory response. If we did have a respiratory response, would we have the problem to begin with? No, right? If we had a respiratory response, we become acidotic from respiration. Well, if we had a response that's respiratory, it would have offset it already. You wouldn't have gotten acidosis, right? So when we have respiratory causes of acidosis or alkalosis, we will not see a respiratory response, right? Instead, we'll see only a renal response. So what happens when we have increased amount of hydrogens? Well, the renal system, the kidneys, will secrete more hydrogens into the tubules. It also reabsorbs more bicarbonate, right? By doing that, it makes the urine more acidic. So we can urinate out excess hydrogen. By urinating out that excess hydrogen and reabsorbing more bicarbonate, the bicarbonate goes into your bloodstream, neutralizing excess amount of hydrogens in our bloodstream. When we do that, we are then decreasing the hydrogen concentration, which allows us to go from 7.2, now there's less hydrogen, 7.3, less hydrogen, 7.4. Perfect. Now, metabolic response or metabolic causes, the most common example and the most likely example of metabolic acidosis is from diabetes right here. Doesn't even have to be untreated, right? It just has to be poorly treated, where the person is not taking the medicine. What happens then? If the person forgets to take, and I did see that when I was working with rheumatologists and endocrinologists, people with diabetes, for some reason, right, will either drink a lot and forget to take insulin, or they just don't want to take it sometimes. So what happens? Well, the body thinks it's starving. So even though you're eating, none of the glucose is going into the cells. Body thinks it's starving, brain thinks it's starving. So it's gonna have the liver undergo gluconeogenesis to produce more glucose from other sources. You're gonna have more ketones being produced and more keto acids being produced. By itself, the keto acids aren't very acidic, but when you have a lot of it, it starts acting up and causing the body to become more acidic because there's so much. So anything, it doesn't have to be from, any effect that can decrease the pH by increasing the hydrogen concentration, like in untreated diabetes or poorly treated diabetes, when they have DKA, diabetic ketoacidosis, that can cause us to have metabolic acidosis, right? Now, what is the response? The response, and I do want to write it right here, now we'll see both responses, both respiratory and renal response will be seen, right? Now, what is a respiratory response? Well, the respiratory response is, remember, we're acidotic. So what do we need to do? We need to decrease hydrogen. How do we decrease the hydrogen in our body? We're going to decrease the carbon dioxide. So what are we going to do? In the respiratory response, we need to decrease carbon dioxide. We are going to hyperventilate. Hyperventilation means you blow out more carbon dioxide. As you blow out more carbon dioxide, you produce less hydrogen because there's less carbon dioxide. That less hydrogen counter the effect of the acidosis. In the renal response, what are we going to see? Renal response is what we said before. Increase hydrogen secretion. In kidney tubules and increase bicarb reabsorption in the kidney tubules. Perfect. See how this works now, right? So I do want you to know these. I'm going to highlight it and put it bold. So you know there's going to be more than one questions on the test about it. Yep, and it might be even on the, I'm thinking about having a written assignment for this, not just a test, okay? So then I know everybody has so much to do, so I don't want to make it that much more difficult, okay? Right, now alkalosis is completely opposite. So if you know either one of these for acidosis, you know the exact opposite one occurs with alkalosis. Respiratory alkalosis, what happens? Right? Caused by hyperventilation. The most likely cause is that right here, right? High altitude, right? What happens when you are like in Mile High, right? In Denver, when there's higher altitude, there's less oxygen. Because there's less oxygen, you have to breathe more and faster to get the same amount of oxygen as you would at sea level, right? There's a reason why boxers, right? Why wrestlers all train at high altitude. You guys know that Muhammad Ali was probably, remember, right? I grew up in a different country. So one of the weird things, like coming back and thinking about it in my lifetime, is that when I was a young kid in Indonesia, right? I had not seen Caucasians until I was about 6 years old. Crazy, right? No, didn't even know about Caucasians because everybody I knew back then were Indonesians and Chinese. So when you see, and most of the Caucasians we saw were Dutch, right? So they're tall, 6'2", right? And what happened was, one of the first Americans I heard of was Muhammad Ali. And with Muhammad Ali, he was one of the first boxers to really train at high altitude. When you train at high altitude, there's less oxygen. It increases your EPO, right? Your erythropoietin, which increases your red blood cell count. So then when they fight, they never fight at high altitude. They always go to sea level, where now there's more oxygen. Now you have more oxygen and more red blood cells. What happens? More stamina. Perfect. It's not cheating, because everybody can do that, right? You're not causing some kind of, you're not putting something in your body to cause this. You're actually training to cause this. Now, what happens when you're at high altitude? Because there's less oxygen available, it's really hard to take a deeper, deeper breath, right? You're limited by the muscles and the rib cage. So what can we do to get the same amount of oxygen in as before? We increase the respiration rate. By increasing the respiration rate right here, we can get more breaths in and therefore more oxygen. The problem is, what happens to carbon dioxide, right? What happens with carbon dioxide is this, right? With carbon dioxide, we will see a decrease in carbon dioxide. And therefore, a decrease in hydrogen concentration, right? So that is a secondary response right here, is that as you have higher ventilation, you blow up more carbon dioxide, there's less carbon dioxide in my body, which causes decreased hydrogen concentration in my body, making it now alkalotic or basic, right? what happens? What does the body do to compensate? One, there is no respiratory compensation. So there is no respiratory compensation because if there was, you wouldn't have this problem, right? If there was a respiratory compensation right here, we would, from the increased ventilation, would cause it to decrease. Well, that's not true because we continue to see the hyperventilation. So there is no respiratory compensation, but there is a renal compensation. And the renal compensation is completely opposite of what we saw before, right? Now we are alkalotic. Our blood pH is too basic. Do we want to keep getting rid of hydrogens at that point? No, we need to make it the pH go down. The only way we can make the pH go downwards is to retain more hydrogens. So hydrogens in the tubules of the kidney is reabsorbed and retained. And I do have this, right, in my, what do you call it, on my addendum in more detail. So if you're worried about it, take a look at that. All right, so hydrogen is reabsorbed and retained. Bicarb is now released. So then our pH of our urine will become slightly more basic than it should be. That's the thing that we will see. Next, metabolic alkalosis. This one's really rare. Metabolic alkalosis is incredibly rare. Usually, right, most common people that get this, cancer patients on chemotherapy. Okay, and why? Well, when you're a cancer patient on chemotherapy, one of the things that happens with chemotherapy is that you will see increased nauseousness, increased nausea, increased, right, vomiting. And when you vomit so much, so often, you get rid of a lot of hydrochloric acid. By getting rid of the hydrochloric acid in the stomach, you need to make more hydrochloric acid in the stomach then. And you only get that hydrogen from the bloodstream. So as we get rid of it by way of vomit, your stomach still needs hydrochloric acid. So it's going to start making more new hydrochloric acid. But in order to make more new hydrochloric acid, you have to get that hydrogen from the bloodstream. So as you get and receive more of the hydrogen from the bloodstream, now your hydrogen concentration in the bloodstream is less than what it should be. If hydrogen is lower, you're gonna have higher pH. You're gonna have alkalosis, right? So it's kind of crazy, but that is usually the people that we see. Now there are other, they talk about people that ingest substances like bicarbonate. Do you guys know what, I mean, sometimes the book is kind of stupid in the way they wrote this, right? Because you're like, who would ingest bicarbonate, right? But you know what's in bicarbonate?
No.
Tums. Tums is calcium bicarbonate.
Oh.
So instead of saying like ingest bicarbonate, they should have said ingest antacids. And acids like Tums. Tums is calcium carbonate. When you ingest it, it acts really fast. Why? Because that calcium binds with the chlorine and then from the hydrochloric acid, and then the bicarb, the bicarbonate found in Tums, is able to react with the hydrogen in your stomach, neutralizing it. So it acts really fast because that's its job, is to remove that hydrogen physically by neutralizing it, right? Now, there are people that take so much Tums that they can have, you can neutralize too much hydrochloric acid because you're taking 40 Tums a day. I know, who the hell will take 40 Tums a day? But some people do that, right? And because of it, they get metabolic alkalosis. Again, with metabolic alkalosis, usually very weird, unlikely conditions. The only time we do see it more likely is in cancer patients on chemotherapy, right? Now, what kind of response? now we see two responses, right? One, a respiratory response. What is a respiratory response, right? Again, at this point, we need to lower our pH. So we are going to hypoventilate. As we hypoventilate, I'm going to retain more CO2 and more hydrogen produced. Perfect. We'll also see the second response as well, right? Right here, the renal response. We'll see here. And the renal response is, let me just make this more in italics. The renal response is hydrogen is actually not reabsorbed. Hydrogen, where did I get this from? Right? Hydrogen is reabsorbed and retained. Bicarbonate is secreted and released into urine, right? Our urine pH is now lowered. All right, actually, urine pH is higher. Why is that lower here? Now I know why people don't like using Keynote. Okay, again, look at my other set of notes for the addendums for acids and bases and acidosis, alkalosis. They are probably, and I do have a video just on acid bases, right? And acidosis and alkalosis. That's linked already. So review those and review the videos here that we just, I'm gonna post up, right?
Okay.
I'm gonna save this, right? But the thing is, I want you guys, I have better notes online already, all right? I just can't open it for some reason.
Okay.
You guys have any questions? Right,
No.
for the test, right, and for the assignment, understand the causes of acidosis. And again, if you know the causes, the respiratory acidosis, the opposite's true for respiratory alkalosis. Same thing with the responses, right? Respiratory acidosis, the response is purely renal. Well, we're gonna see the exact opposite response in respiratory alkalosis, right? Purely renal, and what happens? 180 degrees apart. If you know one, you should know the other, okay?
Yeah.
All right, now, I'm gonna stop right here, and what I'm gonna do is then give you guys a little couple of hints right here. Again, I'm gonna give you, and I was thinking about this, I'm gonna give you guys for the final exam and the final lab practical, right? I want us to, I'm gonna give you until May 26th, that Tuesday, to get the last exams done, right? Not Friday, all right, on the 22nd, but you'll have a whole weekend to get it done. So then we'll have a little bit more time, okay? So then you guys can have time to study for this one, do well on this test, and for the next one as well.
Is that a Tuesday at midnight then, or?
Yep, Tuesday at midnight.
Hey, I'm trying to squeeze out all the time.
I know.
11:59 p.m.
Okay, that works.
All right.
Sounds
All right. You
good.
guys have any questions?
No, sir.
No, I'm
Not
getting
yet,
real
right?
religious right now. Actually, we talked about
I
this
know.
before.
I know.
I might have to go to church.